Hello everyone, welcome to my YouTube channel School of Chemistry. Today we are going to study about valence bond theory of coordination compound. I will teach you about 5 compounds, and by using about this 5 compound you will be able to answer all the questions which are related to the valence bond theory in the coordination compound of class 12. Okay, so here we go. The first compound which we are going to study is COF6 3 negative. Okay, so let us start with the atomic number of cobalt. So atomic number of cobalt is 27. What and the oxidation state or number of cobalt in the complex is plus 3. Fine. So let me remind you what is the oxidation state. It is a charge left on an atom when all other atoms attached to it have been removed. Fine. So oxidation state comes out to be 3. Now let us write down its electronic configuration. Electronic configuration. So normal electronic configuration of cobalt is argon 3d7 4s2. Fine, and we have cobalt 3 plus. So for cobalt 3 plus we can write argon 3d6 4s0. Now let us represent it in the form of the block diagram, that in the 3d orbital we're having 6 electrons. So this one is 3d, 1 2 3 4 5, and this is a 6th electron. Then we have 4s orbital, and with that we have 4p orbital also. 4p. Fine. Now the ligand which we will be having over here is the F negative. So we will be requiring 6 orbital. So in that case we will be also using the orbitals of 4d. So this is a 4d. So we'll be requiring 6 orbitals. So these 6 orbitals, that is 4s, 3 orbitals of 4p, and 2 orbitals of this 4d undergo the process of hybridization sp3d2 in order to form 6 new hybrid orbitals. Okay, in order to accommodate the electron from the 6 F negative ion, that is fluoride ion. As fluorine is a weak ligand, or you can say weak field ligand, it cannot cause pairing of electrons in the 3d orbital. So we have to use the 4d orbital for the hybridization in the complex. So this is how we are representing the 3d orbital having 6 electrons. Now this is your hybrid orbital 4s, in which the F negative is going to donate this pair of electron. We can represent our 4p as this fluorine is donating its electron, and then from the 4d F negative over here and F negative over here. Fine. So this is how the complex is formed. So as a result, the complex form, shape of the molecule or the geometry of the complex would be octahedral. If we talk about the magnetic behavior, then we have 4 unpaired electrons. It would be paramagnetic. And if we talk about the inner orbital or outer orbital complex, then we are using the outer d orbital in the hybridization of this complex. So we can say that it is an outer orbital complex. Outer orbital complex. So these are the things which are being asked in the examination. The first thing which is most commonly asked is about the hybridization, about the shape of the molecule, about the magnetic behavior, and the fourth thing is whether it's an outer orbital complex or it's an inner orbital complex. Okay, now the next complex we will be studying second is COCN whole 6 3 negative. Again we are taking the cobalt over here. So the cobalt having atomic number 27, the oxidation state is again +3. So we can write down the electronic configuration for the cobalt as argon 4s0 3d6. This is for cobalt 3 plus. Fine. So we can represent our 3d orbital as this. We will be having then 4s orbital, and after that we'll be having the 4p orbital. So we are having 6 electrons in 3d orbital, and 4s and 4p are empty. But as we know, Cn negative is a strong field ligand, so pairing of electrons is possible in 3d orbital. As a result, we can represent it like this, that the 3d orbital has 6 electrons. They will be only in the, we can say, 3 blocks, and the 2 of the d orbital is empty. This one is 4s, and we have the 4p orbital. So now these 2 orbitals of 3d, 1s and the 3 orbital from the 4p undergo the process of hybridization, that is D2sp3. Now as the complex is having hybridization D2sp3, the shape again will be octahedral. Okay, it do not have any unpaired electron. So when we talk about its magnetic behavior, it would be diamagnetic. And as it uses inner d orbital in its hybridization, it would be an inner orbital complex. Fine. So these are the things which are being asked in this. Next, third compound we will be talking about is NiCl4 2 negative. Now as we know, the atomic number of nickel is 28. So for this we can write down the electronic configuration as argon 3d8 4s2. Okay, now oxidation state of nickel is +2. So for nickel +2 we can write down argon 3d8 4s0. Okay, and represent it like this. 3 4, we have 3d orbital, 1 2 3 4 5 6 7 8. So 2 of the electrons will be left unpaired. We have 4 empty 4s orbital and 4p orbital also, which is also empty. So we will be requiring 4 orbitals for accommodating the lone pairs that will be given by the chloride ion in the complex. So as the Cl negative again is a weak field ligand. It cannot cause pairing of electrons in 3D orbital. So we'll be occupying 4s and the 4p orbital, and they undergo hybridization, that is 1 4s and 3 4p undergo the process of hybridization, which we call as sp3. 4s and these 3 4p, they undergo hybridization and sp3. As they undergo sp3 hybridization, 4 hybrid orbital will be formed, which will be accepting the electrons from the Cl negative ion, forming a tetrahedral complex. And as it has 2 unpaired electrons, it will be paramagnetic. So hybridization, shape and magnetic behavior. Our tetrahedral complexes are not considered as the inner or the outer orbital complex because they are not involving the d orbital in hybridization. Next comes the fourth compound, that is NiCN whole 4 2 negative. This time the oxidation state of nickel is again +2, and we can write down its electronic configuration as argon 3d84s0 and represent it as this is our 3d orbital containing 8 electrons. This one is the 4s orbital, and then we have a 4p orbital also. Okay, now Cn negative is a strong field ligand, so it pairs up the electrons in 3d orbital. So they will be represented as this one is our 3d orbital, and we have one empty 3d orbital, 4s and 4p. So this time 1d, 1s and 2p orbital will be involved in hybridization, that is dsp2 hybridization would be there. When d orbital is involved in hybridization along with sp2, the complex form would be square planar. Okay, as we do not have any unpaired electron, it would be diamagnetic. Okay, square planar diamagnetic, and the hybridization will be tsp2. Okay, now the last compound, fifth compound, is NiCO whole 4, that is nickel tetracarbonyl with no charge on it. So oxidation state of nickel would be 0. Oxidation state 0, oxidation state or number. It means the electronic configuration in this complex of nickel could be written as argon 3d8 4s2. So we can represent it as we have 8 electrons in the 3d orbital, 2 electrons in the 4s, and we have an empty 4p orbital, which is empty. Now again, CO is a strong field ligand, carbon is a strong field ligand, and it pairs the electron of 4s orbital into 3d orbital. As a result, what will happen? This 3d orbital gets completely occupied. 3d gets completely occupied. 1 2 3 4 5 6 7 8 9 10, and our 4s orbital will get empty. 4s orbital gets empty, and 4p also is available, which is also empty. So this time in the hybridization process, 1s and the 3p orbital will be used, and it would be having sp3 hybridization. As a result, the complex form would be tetrahedral, okay, and it will be diamagnetic, and it do not contain any unpaired electron. With the help of these 5 complexes, you will be able to answer all the questions which are there in the CBSE curriculum of class 12th. So hope my videos are helping you in your studies. So for more such interesting videos, please like and subscribe to my YouTube channel, School of Chemistry.